So let's go ahead and work a few examples of using these new signal operations. In this first example video, we'll just keep it pretty simple. We'll just do one type of operation at a time. So we're going to be working with the signal x of t that looks like this. It's kind of this rectangle followed by a triangle. So that is our base signal x of t. And then we're going to be performing various operations on it to reverse it and scale it, compress it, things like that. And we're going to do 4 different little examples. So in part A, we are going to sketch the signal x1 of t, which is equal to a time-shifted version of x of t. So we need to sketch the signal x of t minus 2. Well, we know what x of t minus 2 means. That is a time shift. And it's a time shift 2 seconds to the right. So it's a delay. Things slide to the right. So to sketch x of t minus 2, we need to just take our original picture and shift it 2 units to the right. So the way I like to do that is to pick points. So minus 1 is going to have 2 added to it. So it's going to turn into 1. 0 will turn into 2. 1 turns into 3. 2 turns into 4. So it's the exact same picture, just delayed by 2 seconds. So that is x of t minus 2. All right, that was pretty easy. Let's do another one. Let's sketch the signal x2 of t, which is equal to x of 2t. So this is a different operation. This is a compression. The scale factor on the time variable t is a number bigger than 1, so we know this is going to compress in time by that value. Since it's a value of 2 sitting right there, we know it's going to compress in time by a factor of 2. So again, what I like to do is I like to go back to the original picture and I look at each value. What used to happen at time 2 will now happen at 2 divided by 2 because my compression factor is 2. So that's going to happen at 1. What used to happen at 0 still happens at 0 because 0 divided by 2 is 0. What used to happen at minus 1 divided by 2 is a negative 1/2. So this edge will now occur at minus 1/2. So if we draw it, it looks just like our original picture, except all the points have been divided by 2 essentially. So that is what our compressed signal looks like. It's been squished in time. All right, let's do another one. x3 of t. x3 of t is equal to 0.2 t. So this is another manipulation on time variable. We've replaced t with at. In this case, a is equal to 0.2. Since a is less than 1, we know that that is going to be an expansion in the time domain. And the amount of expansion is 1 over 0.2, or a value of 5. So we're going to take our original picture, we're going to stretch it out by a factor of 5. So I need a much bigger time axis. We play the same game. We go and we look at our original picture and we pick points on the time axis. So for instance, it used to end at time t equals 2. Well, 2 times 5 is 10. So now we know the signal is going to end at time 10. It used to start at time minus 1. Minus 1 times 5, because we're expanding by a factor of 5, is minus 5. So we know our signal is going to start at time minus 5. Things that happened at 0, 0 times 5 is still 0, so what used to happen at 0 still happens at 0 in this picture. So I can go ahead and draw my picture. It looks exactly the same. Rectangle followed by a triangle. It's just been stretched out in the time domain by a factor of 5. And then finally, let's sketch the signal x4 of t, which is equal to x of minus t. So this is a time reversal. I'm going to just flip things on the time axis. We're going to reverse things in time. So I just need to take my original picture and flip it. So originally our triangle went out to time 2. When we reverse that, we know it's going to start at minus 2. Originally our rectangle on the left started at time minus 1. If you negate minus 1, you get 1. So we now know our rectangle has to stop at time 1. So I can sketch my time reversed signal. So that wraps up this example. We did 4 little examples of operating on signals, but these were just individual operations. In the next video, we'll do an example where we actually do combined operations. So we'll do some scaling and reversing combined, things like that. A little bit more challenging.